Welcome to Alchemy Wizard. I'm Tom. Alright, let's get to it. Today I'm going to do call it a final summary of the laser project. Now I'll link in the description to the previous videos that I've had in the laser project. I've also made a playlist about it too because it was kind of involved. So this is the laser rig here. It uses 4 inexpensive $10 laser pointers to focus a beam on the bottom of the beaker where we keep the metal and create colloidals at them. It was an experiment on if it would work. At first we thought I was going to be melting the metal to create the colloidals because that's the typical way that this experiment is run. You take a high power laser, you put it on the metal, you obliterate the metal, you vaporize it, and then it creates a colloidal. Well, the only way I could realistically do that was with probably magnesium or maybe zinc, because the melting temperature of that is low, and these lasers are not exactly high power lasers. That was okay, it was just an experiment. The unexpected result of that experiment was that we did not obliterate any material because of heat. We removed material because of something I'm calling photon electron excitation. And the best way I could figure out is what is happening is the laser is exciting the electrons in the outer orbit of the metal and causing that electron to gain so much energy. The laser light, the photon light, is causing that outer electron to gain so much energy that it is flying off, and once it does that, the metal disengages itself and goes into the solution. And then whatever can happen at that point it turns into a colloidal, is what we found out. But I mean, other things could happen. Nothing could have happened. It just could have, fell to the bottom of as solid material, and nothing ever happened with it. But with the experiment, we were able to create colloidals. You can go and watch all of our back videos on it. I find it's quite fascinating and has a lot of potential for the future. But I need to close the chapter on this and give you my final impressions of the whole thing. And the metals that I used were copper, magnesium, vanadium, zinc. These were my primary 4 metals. And the reason I made these 4 metals was because these are hard metals to create colloidals out of. Now, this is copper C2C1, and you'll notice it's bluish color. Actually, the colloidal content in this is extremely low. The blue color in this is because of the high ionic content that comes from when you cook low voltage electrolysis, copper, cyan, and green. Now, when I cook copper using the plasma arc, I get what we call copper zero. There's no oxidation state at all when you cook with plasma arc. But copper zero doesn't last from the plasma arc. It disintegrates real rapidly, and before you know it, in a week or two, you don't have very little copper zero left. And cyan green copper is great for nasal allergies and things like that. The body does like it too, and it's good for your hair and your scalp, and also for healing on the skin. But copper zero is probably a little bit better internally for absorbing copper into the body than the more traditional this copper. So I wanted to create a stable form of copper somehow for my forever mix to use, and that was the main purpose of the experiment, was to create stable forms of these metals that seem to be possibly hard to create. So anyway, it's now been a few weeks since I cooked these samples up, these solutions up. I actually have a whole big thing of copper here because I wanted to see if we can make 500 milliliters of the laser stuff. So this has a very large amount here. Now, let's take these and put them in the laser microscope to see if we still have colloidals, because that's the point of the experiment, to find out if we have colloidals. So first, copper. I'm going to take the copper thing, I'm going to put it over here into the microscope, and of course I will be shooting the video pictures of this as I do this, so you can see it close up, not just looking at the image in the video microscope. So this is copper done with the laser. I mean, the good part is it's still stable, which is good, because normally it would have disintegrated by now. And it's a little jumpy today. I don't know why. Anyway, this is probably a 12 parts per million copper solution. I would like to get a 20 parts per million copper solution, but hey, this is with the laser. You know, all of these processes here that I did was over 300 minutes of laser application to cook to the concentrations we're going to see here. And I could not run the laser 300 minutes straight. I would have burned them out. So the most I was able to really use the lasers was 15 minutes at a time, let them cool down, do another 15 minutes. It was really a very time-intensive process, but the experiment is what I needed to do. So anyway, copper, 12 parts per million copper. That is, I would say it's a success, except that the parts per million is kind of low. I like my colloidals at 20 parts per million. There's nothing wrong with them at 10, but I like them all to be around 20. This is magnesium. Okay, so let's throw the magnesium in here and see what we got. Come on, there we go. Zoom in on the magnesium here, and voila. Okay, I put this magnesium a little higher, probably over maybe 15 parts per million. There's some little tiny spots in here which show that it might actually be reaching towards 20 parts per million. And that's pretty darn good, because magnesium is the hardest, one of the hardest ones I have to create stable colloidals out of, is magnesium. Plasma arc, it's difficult, and low voltage electrolysis, a lot of times the only thing you get in magnesium is just magnesium hydroxide sitting in there. In which case, actually I'm going to have a video on how you remove the magnesium hydroxide from your low voltage electrolysis magnesium, and in so doing actually increase the colloidal content. But that's an upcoming video. I'm waiting for my chemist to send me the stuff that we can do this video. So, all right, so that's magnesium. Magnesium, I would say, is another success story, though. Like I said, 300 minutes to cook a colloidal is okay for personal use, I'm sure, but for production use, that's a problem. So, I'm going to skip vanadium. Let's go to zinc right now. Zinc, again, is another tough metal to get a colloidal out of. And zinc is another one where we get a lot of hydroxide in there. Zinc particles floating around that just don't become anything. They just float around in the water, and you got to filter those out. And by filtering those out, you actually do increase the zinc content a little bit. So, okay, so now we've got zinc in here. Let this stabilize a little bit. And not extremely impressive. I would put this at a 8 to 10, maybe a 10 parts per million zinc solution. To me, 10 parts per million zinc is not high enough. I would much prefer to use low voltage electrolysis zinc and cook it to 60 parts per million, and then cut it down to a 20 parts per million solution by adding some distilled water. So, while it did work and it is stable, we can get a higher amount of zinc from low voltage electrolysis zinc. But then we have to filter out the hydroxide with the zinc. So that's an extra step too. We don't have to filter out the hydroxide for this, but the concentration is low. Now vanadium, that's my latest metal going into my forever mix, which is the cornerstone of what I call my blood control trialogy, which is chromium, cobalt, and vanadium. And I was unable to get any vanadium colloidals at all in either low voltage electrolysis or plasma arc. I could get vanadium and plasma arc for a short period of time and it would disappear. So let's do vanadium. I did him last because I think his results are really the most spectacular. Everything that we've gotten here. That is vanadium. Kind of a little busy, but it's almost a 20 parts per million solution of vanadium. That is absolutely impressive for vanadium, let me tell you. So, I mean, if I had to say about this, the vanadium certainly is a success story. Now, let me just, I got the plasma arc vanadium here just to show you the difference between several weeks of cooking plasma arc vanadium as opposed to several weeks of cooking that the laser vanadium. And look at that. Most of the vanadium is gone out of this thing. This is probably no more than a 6 parts per million vanadium solution using plasma arc. And as far as low voltage electrolysis vanadium, yes, it'll give you this light bluish stuff, but it's mostly an ionic substance. It won't give me any more than what this is, about 8 parts per million stuff. And I found that the ionic component of vanadium is not that effective for controlling blood sugar. So it looks like if I want to continue, I want to make stable forever mix, I need to use the laser vanadium, which is going to take me. Luckily, vanadium, you don't need a lot of vanadium in your body in order to make it work. So it doesn't require a lot of vanadium in the forever mix. So that will I don't have to make a lot of it. So if I have to spend several days making 500 milliliters of vanadium, it'll go a long way. So that's what we got. That's my results with the laser rig. I think the process could be more efficient if I had more powerful lasers. But, the Hunter, you can get skin lasers, but they diffuse the light. They don't produce a single light. I'd have to disassemble the skin lasers to get a single beam of light. So they're about $100 a piece. They're much more powerful than these lasers, but again, I don't know if it's practical. This does work, but it's a slow process. So if I think to make the process more production worthy, a more powerful lasers would be needed, though this setup does seem to work if you don't mind giving it the time and effort to create it. So that's my really brief discussion on the laser process, and I hope you've enjoyed the series. And I'm not abandoning doing any more laser stuff, but the interest in the laser videos seems to be diminishing. So I'd like to move on to other videos that you guys might find more interesting. But for those of you that are watching the laser video and wanted to know what my final results of the metals that I did test with it, this is my final results. So, all right, I'm Tom, Alchemy Wizard, and I will talk to all of you again soon. And thank you very much for visiting my channel, for liking me. We're getting close. We're to 1,000 subscribers. Come on, you push my channel. Recommend it. Hey, take care. And if you made it to the end of the video, you got yourself another cool. One of these days, I'm going to let you know what you can do with those cools. But for now, having the cools is cool.